Hey, Kool-aid Krew. Somebody give me a 5 for 5 as I get started here, if you would. And please share this one out, guys. This is it's a pretty big eruption, guys. It looks to be like one of the biggest ones this sun cycle. This thing is huge. I wasn't able to show it to you guys a few hours ago, so that's why I'm here already this quick. But it just is what it is. So I just wanted to make sure you guys are seeing this. It does look to be moving pretty fast, and we'll dive a little bit more into that here in just a second. But it's the flare itself is like just ongoing. I am, and what's happening now too, guys. Check out this sunspot. You see that? So what's going on right now is because of this, I do think that the rest of the sun is getting hyperactive, which means that these sunspots are connected, communicating with each other magnetically. That just is what it is. Let me make sure that are we good there, guys? Are we 5 for 5? I just want to make sure before I get too stinking far into this. Hey, Trinity, good to see you. I hope you're doing good, girl. Been doing some good videos over there. Guys, you guys need to get over and check out her channel, okay? Everybody, please do that. We got to support one another. Are we 5 for 5 or am I? Okay. Okay. Just making sure. All right. Awesome. And, you know, guys, I don't like doing live streams this close together. Literally just got off stream. I don't know what time was it. I think it was after, just a little bit after 6 when I got off there the first time. But it does allow me to get in contact with people I don't typically see because I'm not streaming at that time when they're up doing their thing, right? So that is a positive. But, yeah. But typically YouTube doesn't like people like the, you know, the stuff getting posted so close together. A lot of times the notifications won't get sent out correctly because of that. They won't send out like a third notification in 24 hours. This is just the second one. So I'm hoping that this one's still going to get out there. I will be coming live again. If anything big happens, I'm not leaving right now. So don't think that. I'm just giving you guys a heads up. Axe is probably going to come on with me tonight. Around 9 or 10 Eastern, and I'll be giving you an update at least then. If something big happens, if we get another X flare, I'm going to come back on here. And that's what I always do, just trying to keep you guys updated. So, yeah, and anybody that's not a member, you might consider joining, because I'm going to be doing a members only stream sometime today or tomorrow. We had a lot of fun the other day. During the members only, we were watching some crazy chiropractic reacting to some videos, but we have a lot of fun over. That's what the members only is. We just try to have fun and laugh, get rid of all the negativity. But anyway, check this thing out. This thing is huge. It really is. I was actually kind of surprised when I went over here and looked. Now, guys, you guys know that when I look at like flares and stuff, we don't always get these big, massive eruptions with them. But this one is big. I got this slowed down. Okay? So, let me go ahead and just kind of time this out for you. Okay? We're just now seeing the edge of this right here. We get an image every 12 minutes over here on Soho. Alright, and this is the one from our perspective, the satellite. It's just 1,000,000 miles closer to the sun than what we are. So, in 12 minutes it travels that far, right? Now remember, the white circle over here is the surface of the sun. This is a real disk. It's a physical disk on the imager to block the glow of the sun, so you just can't, so the imager can even get an image at all. But we get about an hour lead time here between the surface and when we can first see the energy coming off the sun, right? So from there to there is an hour. Now, if I back this up there to there, it traveled an hour's worth, however you want to put that, right, in 12 minutes. So, this thing is moving. That's what I'm trying to tell you. Okay, so and that right there, that is a just very dense blast. This thing is, it's a big one. Okay, now in our favor here, this is pointed more towards the south than it is equatorial. Okay, in other words, it's not directly horizontal with us. It is still facing this direction, but in this instance, it might not matter a whole lot as far as getting a decent shot from this thing. Now, obviously, if you get hit in this area, right, I mean, it's going to be the biggest it can get you, right? But you got to remember that we're still kind of in the middle here. But if you could take this CME and just roll it horizontal, that part would actually be not hitting Earth. It's more so over here. But that's still a pretty good direct hit. It's not going to be no glancing blow like what's going on right now with the previous CME from this same sunspot. It's giving us a glancing blow right now. And it's not doing much, right? This is probably going to be different, okay? It's had roughly about 2 days of rotation. Okay, here's the first flare, right? And we're getting a glancing blow right now, and I can show you the glancing blow right here. Okay, right there. There's the first CME from this same sunspot. And guys, look, check this out. This flare was actually more powerful than this one. It's just if you look at the time that it was actually flaring, and what's happening now is this went up here and it stayed up in R3 radio blackout levels for a good amount of time, an hour or two. Then it slowly tapered off. This is a true long duration flare, okay? But look what's happening here now. It got down here and then it flared again. Not like that much, but something on the sun was flaring. And then it kind of came back down and it's flaring again currently. The X-rays are staying in R1 range, and it's been at least 9 hours now. So that's a very significant thing, okay? And, right here, latest observed, R1. That's where I would look first. Now, they did push back the geomagnetic storm that we were supposed to get at the beginning of the day here on the 26th. They pushed it to the end. Now, I also looked for this to change because this erupted right here. We may see them put some stuff here on the 28th because this thing is moving fast enough that there's a chance that it could get here by the 28th. If that's the case, and it actually does, we're going to get hit pretty decent. That's a fast mover. Okay, we're talking over 2 million miles per hour at that point. Okay, and I just showed you guys how dense it was. That's just dense. Dense, highly charged particles, and lots of them. So yeah. And if our magnetic orientation is correct, such as the BZ that I talk about all the time, if it's at -6 or more negative, what happens? Right? We couple with the geomagnetic fields inside the CME, and we draw it in even more. So, yeah, if all that plays out, we could see some stuff from this. I'm not saying grid down, okay? I'm never going to say grid down except for one time. And that's the time that we're going to have grid down. Because I'm going to be 100% positive before I ever say those words. Okay? Even if I can get out here and tell you. Most likely I won't even be able to give you a warning. And that's why I do this, and I try to show you guys how to look at the stuff for yourself. Because on big events like that, most likely, I'm not going to be able to give you any kind of warning at all. First off, I have a family myself, so I'd be taking care of all that. Now, pop it on for 2 seconds and saying, hey, you know, it's go time, Kool-Aid Krew. That's probably pretty much all I would say, but, you know, at that point, we probably wouldn't even have our technology. It would probably be gone already. So, I'm just saying. And a blast like that is most likely going to get here in like 12 hours. Okay? Because it's going to take something like that to really knock our grid out. It's going to take something extra extraordinary that I've not been able to show you even close of how big of a shot it would take. Now, with that being said, you know, again, if we have that perfect storm scenario coming in there, right? Then we could talk about having 2 or 3 different CMEs back to back to back to back, which is also a possibility when we're talking about big time grid down stuff, right? But it'll take a whole lot to get us there. Our infrastructure is, you know, I wouldn't call it the best, but it's not the worst either, guys. None of us have been walking this planet and seen a blast that's going to do something like that. None of us. So we really, we got some really good ideas and theories of what exactly would happen, but we don't know for sure. So that's why we prepare and we're not scared, right? If you're aware, you don't get that shock scare, and if you're not in a state of shock scare, you make better decisions on the fly. The people that are going to be really screwed are the ones that just totally ignore this and don't learn anything about it, and then all of a sudden it happens, and then what's going on? They're standing in the middle of the street in the dark because everything's out, and they're wondering what the heck and why. So, but I'm confident that you guys will at least have some sort of idea. You got crash. As posted above, I got crash. Not sure what that means, brother. Oh, okay. Massive and fast CME from the big long duration. Okay. Oh, yeah, I can show you Stereo A if you guys want to see it. I don't usually show you guys that one because the definition, the resolution on it, sucks unless you give it 2 or 3 days for them to update things. It's not really all that great. So here's Stereo A, and I imagine this is probably going to blow your mind. I haven't looked at this yet. Okay, right. Well, over here on Seeds, it's not giving us much on Stereo A yet either. I can go look somewhere else, though. It's starting to show it right there. Now, remember, guys, this satellite's closer to Earth right now. It used to be out here on the side, about 90 degrees. It's not there anymore. It's outlived its lifespan, so they brought it back close to our planet. They still use it, but they don't use it how they used to. I'll just say that. Now, also, I want to point out, look at this. Our radiation is still climbing. This is a very gradual incline of this solar proton flux, which is how we measure radiation storms. If it gets up here to a 1, be an S1 radiation storm, which absolutely means nothing to me and you. That even their own scales will say that. There will be no biological effects or anything like that until you get to like S2 range. Then it starts out slow, and obviously the higher you go, the more progressive and more intense the effects get. But do you guys see how long this is? This is amazing. This is a very long duration flare. Now also I want to point out, it's not all coming from the same sunspot. Okay? when we are looking at the data for flaring, we cannot say all the X-ray is coming from this sunspot, right? So anything that's happening on the front of the sun, the disk here that we get to see, right? Any X-ray being produced on the whole front of this is the reading that we're seeing here. So when I explain this, like during solar minimum, our base is down here because there's just no sunspots. That's why. Sunspots are a constant producer of X-ray even when they're not flaring. Okay? So our base level rises when we start getting more and more sunspots on the sun on our side facing us. Right? And remember, X-ray is light, so it's going out in all directions equally unless it's acted upon by some other force, which, yeah, we're not going to get into that right now. But for the most part, everything that you see flashing on this is hitting Earth. But we cannot say it's all coming from here. We can't even say, hey, 75% of it is here and 10% of it's up here. No, we can't say that because we just simply don't know. You could take an educated guess, and we would probably get pretty close. But, you know, at the end of the day, doesn't matter. Not really. You know, if we're at X-class range, we're at X-class range. That means that we're having R3 radio blackouts. That's what that means. Anybody on the day side of the sun is experiencing, and see, look, yeah, we're getting ready to get into a radiation storm. I'm telling you. I said this in my previous live stream. So right here is this flare hitting, right? It hits, doesn't go all the way away, kind of comes back a little bit, still hanging on. Now look what happens on our pole regions. See that? That's a radiation storm that comes in on our poles. The flare shows up on the day side of a planet like a bullseye. That's your flare. This is not your flare. Okay, protons take some time to get here because they have mass, right? So, but they can get here within 20 minutes to an hour, depending on what's going on. And they usually get here because they have crossed our magnetic connection line to the sun. And what I mean by that, and I'll just pull up NASA's CME tracker. Maybe they got this one updated now. I just checked it a few minutes ago. Let's see. That was NOAA's. Sorry. Let's get NASA's up here real quick. Yeah, they haven't got this updated yet. But if there's a CME that pops off over here on the right side of the sun, this dashed line is our magnetic connection line to the sun. It's called an interplanetary magnetic field line. Okay? So when a CME crosses that, any protons in that will grab a hold of. And we can take a shot right off the back here. A CME going 180 degrees the other way can give Earth a radiation storm because the protons are so intense. If it's anywhere near our field line here, our field line will grab it and pull it right into our system. We'll couple with it. Okay? So that is what I'm talking about. Now, remember that something else I'll point out here while we got this one up. This square box right here, number one, that's Venus, that green one, that green ball. This green square is the Parker SP probe. It's hanging out by Venus right now. I think it's supposed to do like a slingshot maneuver here, and it's going to be going back towards the sun, and it's going to get back up into the atmosphere of the sun again, the corona, the closest approach it's ever had on Christmas Eve. That's pretty cool. And the first time it got in there, it got some really good readings, and it started helping us understand why the corona of the sun, the atmosphere, is hotter than the surface. That's always been a big question for a lot of people. And they've got some really good ideas and theories and stuff on that, but they can't hammer it down all the way until they get, observable data. You have to have that. Or at the end of the day, it's just an educated guess. So that's why they're going to send that probe back into the atmosphere there again. But as far as this current eruption, this is the 304 angstrom, and this is SDO. It's from our point of view. This is extreme ultraviolet, what you're looking at. They filter out all light but the 304 wavelength on this particular image. Okay? So what we're looking at here is ionized helium. And we look at specific gases because it shows up in specific angstroms. That's all you're going to see. They could give it any color they want. Color is basically by the user, right? If it's daytime where you're at, you go outside and look up, the sky's blue. Do you guys really think the sky's blue? Think about that for a second. It matters what the substrate is. I worked in printing for over 20 years. Hey, Tyrant, trying to survive. Thank you. Appreciate that. Thank you for the super chat. Awesome. Awesome, awesome. Let's get that highlighted there. Thank you. Appreciate you. But, yeah. Did that show up? Let me make sure. Yep, it did. Okay. I just want to make sure it got highlighted. Anyway, so yeah, the sky's not really blue. It's only blue by the way we look at it, because we're looking through our human eyes into the atmosphere, and light gets refracted in certain ways, and certain optical viewpoints from even different species will see it different. It's much like dogs see color different than us, right? What's blue to us may not be blue to the dog. I know we're all brought up thinking that the dogs see black and white. Well, the dogs see black and white to the extent that that's how we perceive black and white. But the dog knows the difference between blue, red, all those colors, because to their eyeballs, red always looks the same. That makes sense? Just like blue always looks the same to them. They're not going to come to you and say, hey, the sky's blue today, and then tomorrow when they go out and look, it's going to be green or something, right? It's always going to be blue for them. Or for us anyway. But if it, you see what I'm saying? I hope I didn't confuse people with that. But that is what goes on, guys. We have to understand those kinds of things so we understand what we're actually looking at when we look at this model. Right? So if we look at different angstroms, we're able to see different definitions as far as the way that this looks. And it gives us a better visual understanding of what's actually our reality. So if I was to show you this, and then go to this, or this, it looks different, right? This to this. Here you're seeing a lot more like crystallines, because you're seeing ionized helium, and you're seeing more of a magnetic connection lines. That's what these dark ropes are. Those are filaments, and we're able to see the particles travel on those lines, right? But if we come over here to the 94 angstrom, same camera, same view, just we're seeing the 94 wavelength, right? We see more of the atmosphere. See how it's more hazy? But we also see how bright the flares are. But we don't get to see that on this one. Now, when this one fires big CMEs and these filaments lift off, it's real easy to see it here. But you won't be able to see a filament lift off here very well. And that, again, this is why we look at different angstroms. But back to the current eruption, that's a big one. But look up here. This is rotating in. I mentioned this a few hours ago. And I think this one here could be the story in about 4 days. 4 or 5 days. If this thing holds on, This thing here, number one, is going to, in about 4 days, is going to be right in front. So if this thing is still unstable, and this one is actually all the way on the front side of the sun, if they both start flaring and erupting at the same time, yeah, we got stuff happening after that. Okay, because this is exactly a very similar scenario to the G5 level storm we had back in May. If the scenario I just said happens, it would be almost mirroring that storm back then. Especially if these things are actually directly communicating with each other, because they'll flare about the same exact time. And that's when you get those big, huge bursts. You know? But yeah. Okay. Now, let's go ahead. And I'm not going to keep you guys here very long because I was just here and I want to make sure you guys, you know, I don't want you guys getting sick of hearing me. You probably already are. But at the same time, I don't want to like be on here too much. Now, I just said something about a sunspot being unstable. What do I mean by that? These are the magnetic polarities inside the cores of the sunspots. You got blues and reds, right? Positive, negative. When those things start getting real close to each other and swirling around, that's when it's the most unstable. We will have a reconnection event when that happens. And when that reconnection event, it's just like taking two ends of a jumper cable and touching them together. You know, bam, there it goes. You know, that's the flare. Now remember, we can have a flare without a CME. But with X flares, typically you're going to get a CME almost every time. We can also have a CME without a flare. So, but when I say something's unstable, it means these magnetic cores are actually starting to swirl around each other, getting close to one another. And the more so that it does that, the better chance it has of you know, blasting off a big flare. Now we're starting to see some more here in the northern hemisphere too. We haven't seen that in a couple weeks. So we got it in both hemispheres now. And it's just going to continue to increase the chances. And I did mention to you guys a few week or so back, we are officially in solar maximum. So, yeah. But, let's see here. But, yeah. So, with that said, chat filter, okay. Okay, now, I do want to run down something. Somebody give me a roll call in there if you would. Give me just a where you're at regionally, and we'll keep moving here. But I wanted to make sure I want to get a roll call in there. I like to know where you guys are from, and it kind of helps people get to know each other too. So if you could, I don't want to know exactly where you live, but just let me know your region, right? State, something like that. And while I switch over here to this stuff, I do want to go over my very simple 2 or 3 chat room rules that I have. You cannot use vulgarity. Please do not spam the same thing over and over and over again. And here's one of the biggest ones. You can have whatever position you want. You can have whatever viewpoint you have. You can put that in my chat. But it cannot consist of any vulgarity or any attack on anybody inside the chat room, and more so, another channel. I don't care if I don't like that channel. You guys know that I don't like it, or kind of assume that I don't. We still don't talk about those things, because all it does is draw drama. And they're not here to defend themselves. As a matter of fact, it's pretty cowardice when somebody jumps in somebody else's chat and slams another channel. To me, that just screams coward. So if you want to rip on somebody, go to their chat. You can rip on me all you want in this chat. I tell my moderators, leave it there. Just don't use the vulgarity. You can call me an idiot, do all kinds of things to me in the chat. Leave it there, mods, okay? As long as there ain't no cussing or vulgarity, if they're attacking me, let it stay. I'll see it, and if I think I need to address it, I will. People are allowed to have their opinion, is my point. So, anyway, I just want to make sure I went over that because I seen some stuff happening in there. I mean, my mods are doing a great job. So, but I just want to, you know, have their back and let everybody know exactly what's actually happening and why. And also, there's something else that a lot of people forget. YouTube will actually block stuff too without us having any control. That needs to be said because that does happen a lot more than what people think. So, anyway. Now, this is Dr. Tony Phillips' webpage, spaceweather.com. Guys, this comet's pretty much a no story anymore, guys, unfortunately. This is the comet that disintegrated pretty much. We're supposed to be able to start seeing the debris of that on the satellites today. Okay? There you go, Linda. That's a great way to say that. Opinions with respect. I'm going to have to adopt, I'm going to steal that from you. That's a good way to say that. Thank you. Well, thank you, AK, forevermore in my heart. That's very, very generous. Thank you for the super chat. I was reading it. That's why I got quiet. Guys, I do have a Rumble, but I don't post there. I've posted a couple things there before. I'm working on getting onto other social media too, because it does help grow the channel. And I understand that some people like to, you know, like to be over there for, you know, other reasons. And I don't, you know, again, I don't really hold an opinion on any of that. It's just, yeah, I am working on that. I do have an X account too, but I don't promote it because I want to eventually use that for communication with all you guys. So I need to do that so I can post my videos there, or at least post a link to come here and watch. But X is actually a great platform for just, you know, simple, hey, the sun dish did this, and then walk away, right? It's pretty good for that. Pretty instantaneous. You can post a short little video there really, really easy. Here on YouTube, it takes a little bit longer to put it together. But anyway, so October 26th, this thing's supposed to hit us today. So is it going to? I don't know. I'm talking about the CME. It looked like it started to here. That's why things started to move here. This is the BZ. We look for -6 or farther negative. Remember that, okay? I'm not going to go into exactly what the BZ is right now, but just know that we look for -6. And over here at Discover, they will highlight this in purple or lavender or whatever your display is, right? Whatever it's showing you there. They just highlight it here. But when we get to -6, we couple with the magnetic fields inside the CMEs. Typically, we will couple with it more. Okay, if it's -6 or more negative, it just draw stuff in easier. Now, vice versa is true. If we go into the positive, we'll deflect better. Okay, so that's why we keep an eye on that. That is one of the most critical points in any kind of space weather data. This really affects everything in a drastic way. We could get a big, serious density hit, and if our BZ's in the positive, we won't even get into geomagnetic storming. Same thing is true if we get hit with something fast. Same thing. All these conditions got to come together at once to really give us a good hit. Now, I also want to say this too, as we look at this again, because we're going to take a look at this again. I'm going to run the whole day here. I'm going to slow it down. Yeah. So, as we're looking at this, we know this is coming at us, right? Now, it looks to me like it is going to be, about 2 days before it gets here. I can't really say exactly how much of this is really going to make it, really put us into geomagnetic storming. It's going to matter about that BZ, and it's also going to matter of how directly we get hit with this thing. If it's more of a side blow, obviously things won't be as intense. Okay? So just kind of keep that in mind as we're looking at this. And please click everywhere you go. You guys, anything you want to see that I show you, if you come to any NOAA Space Weather Prediction Center page, okay, and you scroll down to the bottom, let me get there. You're going to see all the models I use. I use other ones too, but the majority of them are here. Here are the dashboards. Go check them out. But I want to point out Aurora also. Okay, so I want to go to the Aurora dashboard, and any kind of data that you need to see if we're going to get Aurora is right here. All the critical stuff is right here. This is their forecast, the official forecast. This is what they expect tonight. This is what they expect tomorrow night. Okay, this one here might change because of what I just showed you. Okay, right now this is the current Aurora oval. We don't have a whole lot of Aurora right now because we're not getting hit, at least not very hard. Right? This is what you can expect to see if we get these conditions. If we get to a KP of 5, and I know some people are asking me what's a KP, it's the indice that we use to measure geomagnetic activity. CMEs, how hard a CME hits us. If we get to a G1 storm, that's a KP of 5. KP of 7 is a G3, and then a KP of 9 is a G5 and above. Okay? So this is the kind of Aurora we would expect to see during those conditions. So this is a very good hub to come to look at. Hey, thank you. It looks like a huge spider exploding. Heck yeah, it does. You know, and something else that I've noticed, guys, on stuff like that. I already showed you guys the one, didn't I? The spooky CME. I think I already brought that to you guys because it was kind of freaky to see it. It means absolutely nothing. It's just it looked like a face that was coming out of the. What day was that? Let's just go find it. How about that? I think it was back here on like the 22nd, if I'm correct. I think it was kind of like right here. Maybe back a little further, maybe down here. Not there. That's the 21st. I went back too far. Let's go. Yeah, I can't remember where it was, but it's in my 2 videos back. If you go look at it, I showed it to you guys. It was kind of crazy looking. It literally looked like a face coming out of the... Oh, here it is. It's on this day. I can tell by that eruption. Because we had like 3 balls of plasma. Come on. Okay. What about here? Yep, back just a little further than that. There it is. Okay. Let me zoom in. Just so you guys can see it. I just thought it was cool. Let me show you. Check this out. You guys see this big ball of plasma busting off the sun? If you guys look right here, can you guys see that? It's almost like a face is turning from left to right and poking its face through the glass here. So let me slow it down. And I'll pause it right there. Okay, so there's the mouth, there's the eyes, there's the nose. Okay, so let me back it up. Look at that. See? See how it looks like it's just coming, like, just... Yeah, I love this kind of stuff. It makes me laugh. Check it out. Watch. Look at that. Ain't that cool? I thought that was pretty cool. Okay, so, yeah. I got that one. Where was that? Were we here? Nope. We were back further. Okay. So we were down here, I think. Anyway, I just showed it to you guys. So, yeah, I just wanted to show it to you again. I just thought it was really cool. Okay. Now, something that we need to see. Let's do this. I do want to show you guys, and I'm not going to read these, but these are the space weather scales. These are what we can expect during whatever storm level we go to, okay? So come over here, you guys can read this. I'm going to scroll down real slow, and if you guys want to not go to this, you guys can just come to this video and pause it and read, okay? So these are geomagnetic storms. This is what happens when we get hit with CMEs. This is what we would expect to happen, okay? Which includes, you know, depending on how strong it is. If it's a G3 or bigger, that's when we really start looking at stuff because we start seeing significant things there. Now, Aurora is going to be intense on this one when this one hits, okay? I don't think it's going to matter a whole lot. We're going to see some Aurora. But anyway, this is solar radiation storms. Same thing. It gets more intense the further you go up the chart. And this is radio blackouts. This is what we're having right now. We are not coming out of R1 right now. We started at R3, which is the beginning of an X-flare range. And we stayed there, guys. It's crazy. This thing is seriously long duration. Look. I mean, now we're pushing 12 hours here. That's amazing. Now, I will say, the more sunspots we have facing us, I've seen our base levels stay in M-class range for a good amount of time. Now, when we get the spikes, that's when we see the impulsive flares and things. Okay? So, yeah. But, as these other models update, guys, I will be here to give you that update. This is LASCO C3. This is just a zoomed out version of what I've already shown you. Okay? Look at that thing, man. Wow, that's the first time I'm seeing the zoomed out version. You don't usually see that intense color that far out. Look at that. Now, this is a true halo eruption, too. I want to say that. And what that means is you're getting energy showing up all the way around this physical occulter disk. Okay, when that happens, they call that a halo eruption. And then just because it looks like a halo, that's the only reason why. It has no other implications there. It's just visually kind of looks like that. But this can even give you guys a really good idea of how fast this thing is moving. You see how far we're zoomed out here compared to this? Right? We can tell it's moving fast here, right? But if you apply what I just said to this one, it's crazy. Look at that. I mean, that's moving fast. It really is. So, also, I seen somebody was asking me about this. I don't know. I've not seen that before. Just to be honest with you, I have not seen this line right here. Almost looks like if you were to follow it around kind of thing. But that's an awful hard line right there. So I'm gonna just say this: until somebody can show me different, that's probably a satellite anomaly, and I'm being serious with that too. There could be so many things going on inside this imager that could cause those effects, okay? But I will also say this too. I've not seen this look like this before. This is new, okay? I don't know. Somebody asked me about that, and I was like, I don't know. I can't give you a good answer on that. I went and I looked on some of the Soho stuff to see if it was just one of those common anomalies that we see, and I really didn't see much on that, so I don't know. I'm not claiming one way or the other. I'm just showing it to you because somebody asked the question. And I'm just being completely honest with you and telling you I don't know what that is. That's one thing you're going to get here. If I don't know what it is, I'm going to tell you. You know what I mean? So I hope people can at least respect me for that. But yeah. Alright guys, I am going to go ahead and pop off. I do think that we have a good chance of getting into radiation storm level here. Our geomagnetic conditions are actually rising right now. I can show you guys the real time on that, or at least closer to the real time. Let me do that for you guys here real quick. This is the HP. These are 30-minute increments, and yeah, we did get up there here. If we get to a 5, that would be G1 storm. We still got some growing to do here before we get there, but it's getting closer, so we could be getting hit with this sideswipe CME. One thing else I can show you before I get off here real quick would be the let's look at the geoelectric field model, and this is active right now, so we are probably getting hit. Yeah, we're getting hit. There's no doubt about it. That's why we're seeing this thing kind of jump around. This is the geoelectric field at the surface. This is space weather's effect on unnatural electrical components, such as wall switches, wires, your car battery, your phone, any of that. Okay? If it's not made by nature, this is the effect of geoelectric on space weather's effect on those things. They're using this to help forecast earthquakes. Space weather does affect earthquakes. We see a direct uptick in seismic activity every time we get space weather. Corona holes especially. If we got corona holes facing us, you can bet your butt the number of quakes are going to increase, and so will the intensity. And even volcanoes and geysers and stuff like that, we'll see an uptick in all those. But that's that part. Now, let me show you our magnetosphere before we get off here. Yeah, we're definitely taking a hit. Okay, so what you're looking at here, guys, is our magnetosphere, and the magnetosphere is created by space weather hitting our magnetic field. And because of the way we move through space and the direction the energy is coming from, the sun, we get this tail signature, right? We get a bow shock. That's the first point of contact. That's what the bow shock is. First point of contact from our magnetic field and space weather. Okay? Some people will tell you that goes down sometimes. It does not. All it means is that sometimes this bow shock will actually be off of this model. It'll be too far in front. Okay? Or if the speed is the same on this side as it is on this side of the bow shock, it's going to look like the bow shock's not there because it's all going to be the same color. Okay? Same thing is true for the density here. This is density, speed up here. So if the density is the same, notice how you get this big arc right here, and you're not seeing such a big arc here. You want to know why? Because the bow shock is actually right here still, but the density is the same in front of it as it is behind it until you get to this point. Okay, I wonder if there might be a spot here I could show you. Oftentimes there is. Let's see. Yep, right there. Right there. You see that? That's space weather coming. And if you follow this, look, that's our bow shock. But if you were just to look at this, you would think it wasn't there, right? So pay attention to that. Now, here's our magnetic field. Or not magnetic field, it is, but this is magnetic pressure, okay? Again, look at that hit, see? Now what happens, we get compression and then rapid expansion. So we get hit, we get compressed in, we win the war for a little bit, and we push back out real hard. That's what happens. So if our bow shock is kind of living right here, it'll hit us and it'll compress all these magnetic field lines into our planet, right? At least it's depending on how hard it hits. But when we win that battle again, it's not going to go back out to the same spot. at first. It's going to shoot way out here. And then it's going to settle back into its normal position. It's called the standoff position. Okay? So, just so you know, hey, John and Spirit, good to see you. Renee's in here. Sergeant Bun Bun, what's happening? Virginia Trish is in here. Wow. Hey, LMG Fluorepipy. All right. Okay. So, but anyway, guys, that's what we got. If I get anything else, I'll be back on here to let you know. Okay? But thank you guys for the super chats. If you guys aren't members and you want to be, again, I'm going to be doing the members only stream either today or tomorrow. If you do join, go back and watch the previous one. Okay? And the reason I'm saying that, it was funny. Guy had a rubber mallet and a spike and was doing chiropractic adjustments with it. This dude was jumping off the table, screaming and everything else. It was funny. We also watched Zoom Court. Hey, Jennifer, good to see ya. Angel, holding it down the Bronx, baby. Heck yeah. All right, guys. Hey, Mercuriana. Thank you for being here. All right. We will talk to you guys later. God bless. Yahusha saves. And go check out all the channels I always say. Craigolicious, thank you. And you can drink this Kool-Aid.